Alright, today we're looking at being able to simplify expressions using the commutative and associative properties. I'm hoping you've heard of what these properties are before, so if you have, feel free to write them down. Um, but these are two properties that work for both addition and multiplication, and we kind of already know what they are. They have to do with the fact that you can add or multiply really in whatever order you want, as long as you only have all addition or all multiplication. So, the commutative property, which I'll just abbreviate with C, says that A plus B equals B plus A. What this means in the context of a problem is that you could take any two terms in an addition sequence, in an addition expression, and flip it around. The associative property kind of says the same thing, but it's a little bit different. It comes from the word associate, and it's talking about what we have our parentheses associated with, or what our parentheses are around. So what that says is we can, if we have it doesn't necessarily just say that you can move parentheses. That's where you have to be careful. It's basically saying that if we have a big chain of addition, we could choose to do these two first, or we could choose to do these two first, and it really wouldn't matter because it's all addition. Okay, so the question is, how are they helpful? Well, a lot of the stuff that we need to do in algebra involves simplifying expressions. We try to simplify our problem down to something that is a little more manageable, usable, something that we've seen before. But a lot of the things that we do in the simplification process that eventually we aren't going to need to justify, that's what these properties are actually used for. They help us simplify expressions. So let's look at some expressions and how we simplify them. Okay, try to think of how you would simplify this expression. Just think about it. I'm hoping what you're thinking is that you realize you want to try to combine two of those terms, the two numerical terms, the 2 and the 27, combine them into a single term. But how do we do that? Well, you might know how to do that already, but in reality, to do this, we need some justification. Okay, we're going to actually need to use some of our properties above, because right now, what would we do first in order of operations? Well, we would do negative 2 minus x. We can't combine those two terms because we don't know what x is. So if we want to combine the 2 and the 27, we need them next to each other. We cannot reorder the subtraction, but we can reorder addition. So the first thing I'm going to do is I'm going to change this into an addition expression. Okay, so I'm going to change my subtraction to addition to the opposite. Now what I'm going to do is I'm going to use the associative property to get those two guys next to each other. Now it doesn't matter which one you switch necessarily, but I'm going to switch the x and the 27. Now the only reason we were allowed to do this is because of the commutative property, or the associative property. I guess you can make an argument that it was that, but I mean, we'll say it's the commutative property because we flipped the order of this addition. Now, order of operations says we do these two first, we put them together, and then we change back to subtraction. That seems like a whole lot of work just to simplify an expression. Now, in the future, are you going to need to do this and show all those steps? No, you're just going to be able to make the jump from your beginning spot to your answer. Okay, so that's going to be fine. But what we're going to be working on initially is showing those steps and understanding where that justification comes from. Okay, so what I want you to do is I want you to just try this next one on your own. Okay, it's probably going to be a little bit challenging and you may not get exactly right, but pause and then come back and see if you got the right answer. Okay, I'm assuming you've paused and come back at this point. This one's a little bit tricky because we want to multiply the 2 and the 4, but they're not even in the same parentheses right now. So the first thing I'm going to do is I'm going to reorder my multiplication to get the 2 and the 4 next to each other. Okay, and that was by the commutative property. The problem is, what would I do first in order of operations? Well, I would need to do 4 times x. So I need to change the two terms that my parentheses are associated with. So that same property that I wrote with addition at the beginning can also be used for multiplication. Okay, and so I can associate my parentheses with the 2 and the 4 and leave the x by itself. Now I can multiply the negative 2 and the negative 4 and get negative 8, and I get negative 8x. Again, in the future, are you going to have to do that? No. You will be able to just jump right from here. But I want us to just get a little bit of practice with justifying our work. Okay? So when you're doing practice problems, you need to show all the steps, and you need to write down whether you, at any point whether you use commutative or associative properties. Okay, so again, remember these rules work for multiplication too. I didn't write those up at the top, but if you want to, you can. So the commutative rule is A times B equals B times A, and the associative rule would say basically the same thing as the addition one did as well. So if you want to write those two rules up there, you can do that as well because they work for multiplication too. That's it. I know this is a little bit different, but justifying your steps is something that you do in a lot of levels of math, so it'll be good practice to do it on something that you already probably have a decent understanding of. That's it for this one. Hope you learned a little something.